Hi everyone. Um, Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. Today we're going to be continuing our discussion of the series library and the implementation details and design discussions about it. Specifically today we will be covering more details of the underlying API, some theoretical difficulties I actually found in the related paper to the implementation paper. Specifically, I forgot to cover this when we originally discussed series. Specifically, things about portability, things related to side effects, and how um, underlying design considerations of the API as it stands today, how one might be able to improve it at the cost of being able to be adhering to one specific implementation of Common Lisp versus another. So today's the topics that we're going to be covering is mainly the different. We're going to go into details of the different types of series expressions that are available in the library. Now, I did mention scanners, transducers, and collectors, as you probably saw in our implementation series the last few weeks. In addition to that, as some of you may have recalled when we covered series a while back, that there were two additional things that were also introduced in the library itself, although it's not covered as a category of APIs, and those are generators and gatherers. For some reason, the user reference manual in the series paper, which is the AIM 1082, if you actually go back and look at our past episode where I actually posted the two PDFs. I will, again, of course, post the additional PDFs here in this description when we're done today. But if you look at that, they cover about maybe 5 or 6 different categories of APIs. One of the ones that are particularly of interest that we will also be covering today is a section specifically on efficiency notes, where although series does encompass a lot of functional programming um, constructs and concepts and enables you to use the library in a pure functional programming sense, as it stands, it will be actually the APIs actually have a couple of functions that allow you to efficiently modify a given series data structure. So that means you can take in a series expression, you'll be able to alternate the underlying data structure that series expression is spitting out, and the series compiler will actually go in and do certain optimizations to prevent things like, say, additional copies from being created. So this way you will have more of a computational speed up instead of having an I/O cost attached to that. So we'll be covering that. Um, there's a couple things that I wanted to mention also here before we get started, and that is, as usual, Atlanta Functional Programming is looking for people to give talks. If you have a talk topic related to functional programming, either design, architecture, discussions, and it can be in any language that you want. You can just post a comment in the YouTube video and/or contact me. I'm on functional programming Slack, as well as I'm also in the Lisp Discord server too. So last time, just to give a brief review of what we covered last time, we actually went through section 4 of the paper, and what you're looking at is kind of a transcription of the underlying logic for a scanner, a transducer, and a collector. As you probably noticed, just a quick review, scanners are ones that produce elements. You could think of them as data sources. They're transducers. They transform one series into another series. Collectors are essentially sinks. They will actually collect the series expressions into a destination data structure. And in this example, as you probably, just a quick underlying review, we essentially took the paper's example of computing the first 5 elements, creating a generator that will chomp them up and return them one at a time, and then filtered them using this transducer called choosif that will take in a generator and it will spit out an appropriate series that will actually encompass the actual predicate to make sure that those series elements all satisfy that predicate. And then what we did was we passed that to a collector, which took that generation choosif and it summed up the odd elements, as you can see here on line 75 through 77. Now, when we did a comparison between the disassembly of this code, and I already loaded this into the memory, but just in case, let me just make sure. Series workshop. Okay, so I already did this. Okay, so here, just also open up for comparison's sake the test series use of. And folks who are watching on the YouTube stream, please post in the live chat if the font needs to get bigger. I'm trying my best to accommodate to make sure that they all kind of match. So, if we do a comparison with what we have here on the left-hand side, which is our implementation using closures, just pure closures, and as most of you know, once you create a Lambda factory that actually creates an instance of a Lambda, the actual Lambda that's returned will not get executed unless you fun call it. It's a fun callable instance. When we actually disassemble this and we do a comparison of the disassembly, if you recall last week, we ended up having an implementation that is fairly inefficient in terms of just the number of instructions that's actually generated compared to 90 bytes versus 74, if I remember correctly. Yeah, 74. So you have a savings of 16 bytes. But you have to also look at, for folks who are starting to look into and understand these assembly instructions, each of these assembly instructions could have a specific I/O overhead. So some of the instructions might be more expensive than others, but just looking at the difference of the sheer number of instructions that are being executed, you can see that there might be some potential performance bottlenecks in the generated assembly from the closure implementation as compared to the series implementation, the actual library implementation. And there's good reason for this, actually, because the closure implementation, as the author explicitly states in, Dr. Waters explicitly states in his paper, is that it was not designed to produce a very efficient assembly. It's in native code, and the reason for that is pretty obvious, right? One of them is for example, just sheer consing and understanding the types of information that are associated with the given the given arguments for the generator. So right now, a lot of the genericity that's in the assembly code is related to the fact that we're not doing any sort of static analysis on the expressions themselves, figuring out type deduction through type deduction what types are associated with it, and picking the appropriate instructions that might be useful to actually optimize the final native code that's being spit out by the compiler. Now, this is obviously something that's good for folks that are doing rapid prototyping, especially because of the fact that you may not necessarily know until you explicitly declare through type hints or declarations, as most of the common Lispers are aware. You would want to be able to still experiment with your code with different types and have some sort of generic version of those functions being available to you. But when you're dealing with series and series expressions themselves, the genericity comes at a cost of efficiency. And since we're being also lazy here in that we're evaluating on demand the given functions, you have additional instructions related to, essentially branching back to the appropriate function that you're fun calling to actually go and get the next item in the list, or not actually dealing with the list directly itself. So to compensate this, and we're going to be looking through this when we're doing more details of the series library itself, the actual the specific sections of the series library, and more, as we analyze each of the individual functions and sections, you'll see, and it'll become clear that this library really requires some level of type hints to being available in your code, or some level of deduction so that it can, optimize accordingly and give you the most efficient code possible. And the compiler can do that if you give the appropriate type hints, and we'll be talking about that in a little bit. Two things that I want to also bring up, and unfortunately, Dr. Waters' implementation paper doesn't cover this, but the user manual does, because I think it's fairly useful for folks who are actually using the library to be aware that this is something that they need to consider, is that there are two essentially major limitations in or what he calls areas of difficulty in the current implementation. And since series has not really been actively developed or updated since it originally came out in the 90s, this is something also that I think that we've essentially inherited from in this library. The first area of difficulty is related to, at least based on the current design of the series library, is something he calls the theoretical limits of the individual algorithms that are available in the library and used. The second one also deals with interoperability and portability between different common Lisps, because different common Lisps adhere to the standard in different ways, and has such, some common Lisps might be better at generating far more efficient code if you choose to use their implementation specific sub namespaces. So in order to cast a wider net and have a much more generalized library that most people can at least use, certain design compromises had to, of course, come into play. Now, I'm not aware of any specifics as to, my apologies about the little automotive stuff that's happening behind the scenes here. I'm not aware of any specifics as to different common Lisps implementing different things far more efficiently. I think when this was published at the time, there were far more, I would say, diversity in common Lisp implementations. I can certainly say that I'm not an expert in the different common Lisp implementations at that level. I can say that if you, given this specific documented limitation, if you end up switching between different Lisps, whether it be SBCL to CCL, or CCL to, say, maybe even one of the commercial Lisps, whether it be LispWorks or Allegro CL, you might end up getting different results in terms of performance, not necessarily in terms of correctness. So that's something to be aware of. To go into some of the more details about this, there was an example. Let's see if I can pull up that example again. The paper brought up specifically related to specifically related to multiple value returns. But let's go through that. We're jumping ahead of that. So let's first talk about the side effect limitation. Now, it is so there is a belief for folks who are starting to use the library. There's this myth that you might be thinking that when a series expression is converted to a loop, correctness is actually preserved even in the presence of side effects, that is set effable or generalized expander expressions inside your body of code. That is just not true. There are several steps that series expressions does to make those easy to understand, but the thing to realize is series was designed to kind of make sure that you're minimizing the number of side effects as much as possible. So that's the difference between using mapping and iterate versus using a choose if. And we'll talk about that when we start getting into some of the 5 different categories of the expressions. Now, this is mostly related to the fact that since we are using lazy evaluation, the elements that we're doing are essentially cached behind the scenes, because lazy evaluation oftentimes implements the rule of not computing the same thing twice through some sort of caching or memoization. And so internally, if you try and access the same element, it may not be recomputed, it may be just looked up. And because of this, it also means that if you're trying to alter the actual data structure, you might actually invalidate the cache, which will cause some additional problems. Now, we've talked about a lot of stuff related to order of evaluation and the requirement that we need to have some sort of pre-ordering of your expression. So I won't cover that too much here. The one thing I will mention is if you look at the theoretical detail section, or the ugly detail section inside the series common Lisp paper on it, there is a mention as to something that you may want to be careful of when you're trying to improve your particular implementation of a series program. And what I mean by that is ordering your expressions and being able to understand the data flow is absolutely important when you're trying to leverage the series libraries as they stand today, because drawing out that data flow graph will tell you where potential bottlenecks occurs, and additionally, it will tell you or give you an idea on where things might additionally split off. And if you have that splitting off and you have a data flow graph that has multiple avenues, you are violating the idea that they should be kind of linearizable, and that is the second requirement in the optimizable series expressions section. And if you remember those five rules, and I'll just pull them up here for the sake of discussion. Here. This is they have to be this notion of straight line computations. If you have anything that's related to having split off things, you will end up having certain violations, and that will obviously reduce the possibility to optimize your particular series program. So let's go through a couple of things here. Now, there is, to get started inside the series library, something that is similar to what we talked about in terms of generating expressions using some sort of internal counter like this right here. The reason this code of getting the first 5 elements can be done in different ways inside series. One is, and you could certainly do this in different things, is scan range. We've talked about that. You can see that in line 167. That's exactly what I'm using to actually go and grab them. Scan range is kind of similar to the keyword arguments inside scan range are similar to those that are provided in loop, as you guys recall. 1 second here. Just this. If you guys recall, let's do this. It has most of them in terms of iteration, from by up to below down to above length, so and so forth. The last type, though, is very, very specific to be aware of. Scan range by default is assuming that it's going to do type number, so that means it doesn't matter whether it's an integer or float or what have you. So if you guys are trying to use, say, a different type, you're going to have to change the type inside of scan range before you go and generate it. Additionally, there is actually a constructor, if I remember correctly. I'm thinking the series actually still has it. Yes, it does. Called make series, where you could specify a different set of series, and it will go ahead and return. Let me do this in the REPL to make things a little easier. Series, make series 1, 2, and it'll go ahead and generate this series data structure. Now, for folks who are joining us for the first time and have not seen this notation, the #z is actually a reader macro provided by the series library to indicate that you are dealing with the series data structure. And that is something to be aware of. So this way, when you're reading through code or seeing the output spit out by the series library, you're not confused as to what this #z guy is all about. Internally, how the series actually implements the given series expression, I think for the most part from my experimentations with it, it looks like it's using essentially a make array to create a vector, a contiguous vector for the series object that it will then, essentially populate as the fun call on the step function is called. This is related to, of course, the way scanner is required. Remember, scanners usually have an initial value, a binary function related to what the next value should be computed as, and a predicate to essentially be a terminating condition. When are we actually done? There's a way of actually combining two series, and that's called catnation in the series parlance. So you can, of course, do series : catnate, take the previous series that I just created, take another series, 4, 7, 8, and it'll go ahead and, oops, all right, I have to go and actually do, I don't know if this series, I don't believe this is available. Let me just make sure. I don't think it's exposed. The hash function is not exposed. Okay, so what I'll do is I'll just use another make series here. Make series. And you'll see Catnation essentially combining two series and returning a new series data structure. There are about, like I said last time, 18 different ways of actually going through and generating series or scanning different things and spitting out series. I will go through only a subset of them, mainly because one of them is specifically useful for our discussion on the side effect and multiple later on, some of the design discussions that we were talking about earlier. We already mentioned something called scan range. Scan range is obviously like loop generating, through the use of some sort of simple iterable constraints, as you can see, by from, to, by, or up to, and so forth. It will return a sequence that actually follows the increment value that provided. In addition to that, you've already witnessed in the past episode in scan file and scan. What is it? I think I have it up here. We have also scan vector. We have also scan range and so forth. Scan vector, for folks who have not seen this, this will take in the sequence type that we're providing, and then it will spit out a series. It will generate a series for us. So this is useful for folks that are, especially interoperating with other libraries that are returning collection items, and you want to use them in a series fashion. You can use the normal scan function to actually go in and take those collection items and then just convert them into the appropriate series objects. You might incur a overhead just because it's being converted into essentially a closure, but I don't think it will be, at least don't quote me on this, but I don't believe it is a full copy of the actual structure that you passed in. I think internally it somehow keeps a cons pointer to the underlying vector that you passed in, and then it keeps track of that when it's being used in the series expressions. Additionally, we already talked about normal scan taking in a list, which you could certainly do so, and you don't need to specify. I don't believe you need to specify, because the default is a sequence type of list. Scan can take almost all the basic things. There are a couple things related to other hash tables. You could also do scan multiple, where you could scan different scan multiple. This guy, yeah, you could specify all the different sequences and scan them most of them. I think mostly all of the time, all at the same time. So if we do hash def, it will generate essentially a return value of different series that you could then operate on. Like I said, there's quite a few of them. The one that I wanted to actually cover in more detail is one that you might find useful if scan a list for associated list, inclusive for scan lists of lists, scan lists of list fringe, or multiple, or plist, or range, or sublists, or series, or scan symbols. These are all functions that you could actually leverage as part of the scanner library. But if there's one that you don't need to, if there isn't one that actually suits your needs, you can actually use this higher order function called scan function, of which there are two types of scan functions. There's scan function series. Let me just show you this. Scan function and scan function inclusive. So what is the difference between that? I think for most folks this would be pretty obvious, but I'm just going to go ahead and just mention what the documentation says. Scan function from the outset is basically a function that will take in an initial value. So let's say that you pass in let's say that you're passing in an integer. You're going to be generating integers here. It takes an initial value. It takes a step function. If you remember, scan function is nothing more than the very definition of a scanner. it'll take in a step function that will take x, and then we'll set f x increment. We'll go ahead and make this into that increment x, and then it will take obviously a test function. If you don't specify a test function, what ends up happening is this will be treated as essentially a infinite sequence. Yeah, if I remember correctly, this is an infinite sequence. It's not type function or symbol. Oh, that's right. I have to go and specify this as an init function. Invalid number of arguments. Oh, that's right. I thought it was requiring that, but I read before. This is right. Yes. So if you see this guy here, and we go and print this out, you'll see that it will lock up my lock up my what's it? My REPL, because of the fact that it's just constantly generating. There's no stopping condition here. So let me just reboot my Lisp here. When you're using scan function, it is very, very important that you do provide some sort of testing function so that it knows when to actually return the next value. So if we do this, lambda x, let's just go ahead and say let's make this just that. There is something I'm missing. Oops. Oh yeah, sorry. I just realized that I forgot to reload my library. All right. I make that wrong again. Thought I actually. Okay. Oh, right. It has to be less than. Always do this. Mess up something here. Oh, did I have to use this guy explicitly because it's trying to do it? There we go. That's right. Increment f already does a set f for me, so I shouldn't have to actually do this. Let's see if I just do that. Okay. Let's see if this works too. Then we could cover it. All right. I know I had this right earlier. Okay. let's cover what this is, or what I'm doing here. So scan function is a special function. It's a higher order function that allows you to specify essentially the definition of a scanner for given sequence that you're trying to define. There's a couple things that needs to be brought up related to our discussion about optimizable series expressions that I kind of mentioned in the past episode, and I even mentioned earlier here today, but I'm just going to reiterate. And that is this first argument in scan function, which is the type. By specifying the type, you are essentially giving that hint to the underlying series compiler that was built to pick the right options in order for you to to optimize the underlying generation of the actual code. So that's kind of the starting point for the majority of the series data structures, because it's going to take those three functions that we provided: the initial condition, which takes no arguments, although I mistakenly earlier was accidentally using it. The first init function does not take any arguments, but returns the initial value to some sort of internal data structure variable that the series structure has, and then it will appropriately pass that to these two other one-argument functions. The first one being, of course, the step function as defined by our definition here earlier about scanners. So this essentially implements our scanning of a given sequence, and every time you ask for one, it will go ahead and return based on what the predicate provided. Now, you may be wondering, well, why didn't it allow you to create infinite series? Because it said that the test was optional. Well, when you're using this the way I was directly in the REPL, it's not lazy enough to actually go in and figure out it wasn't actually constructing the lazy structure. It was trying to evaluate them immediately. But we could probably do this kind of similar thing, although don't quote me on this. We could try an experiment, which is using chooseIf, which takes in a lambda, say less than, that says less than 100, and but the one thing is here is we're not grabbing we're not actually doing like a take. This is not specifically like a take. Let me see if there's another one. Choose, if I could say choose. Let me see here. Let me see if this works. Series scanf function integer and 0 x. Yeah, I just locked up my REPL. So I will figure out this one thing about scan function related to why it's not actually providing me the ability to do an infinite series here. It's particularly important because later on, when we start discussing how would we leverage series in some situations, say like reading something from a network stream, which would be useful to be able to do that, just so that you could then leverage series in ways where you normally in common Lisp leverage just straight up usocket with threads and trying to implement loop to actually go and grab until a value is actually retrieved, and then do some sort of optimizations on it. Instead of doing that, there should be a way to actually encompass that particular use case by creating an infinite structure and then being able to just terminate it when no more either the socket is closed or no more data is actually coming through. But we will continue on. Let's see here. I missed something in the discussion. Okay. The one thing about scan function that I forgot to introduce is this notion of the ability for scan function to be able to implement return multiple values. So let's take, for example, I'm going to first shrink this guy here. Go ahead and do this so we can actually print this guy out. Oops, that's right, because I forgot that I have to reload. Yeah. Here. Okay, so let's go ahead and retrieve first the first 10 elements to get into this example. Actually, I'll do this as a simple one so I can actually returning multiple values. So in some of our discussions, we did not actually do this, but this is actually kind of an interesting feature for folks that are doing generic types of scanning. You can actually do this to generate different subseries automatically. So like to return multiple values here, we could use values integer here, and what we'll do is we can actually go ahead and implement say an initial value that takes in the x and the number, and what we'll do is obviously let's start with one. Let's say that we want to get the values of the initial value and the x and x squared. All right, simple example. We can define a series that can take in obviously our we can return values integer. This is basically telling the compiler this is what our return value is going to be. It's a series structure that maintains that. Our step function now becomes essentially, it'll take 2 arguments, and it will, we could simply say we're going to return whatever value that, we're going to, let's start this actually at 0, 0. Although really it should be, let's do that. And obviously we're going to increment x, and then what we'll do is we'll return x and x. Then our terminating condition is also going to be that, but we're going to declare and ignore num for now because we don't really need num. Here we're checking to make sure that the first argument is less than 100. So we'll get, well, we're going to say less than 10. Okay. And what is it? Invalid arguments 1. Did I miss something here? Oh, yeah. I see. This values 0. Oops. So, nil is not a number. Let me see here. What did I mess up? Our initial condition is 0. Our summation is going to be and what is our terminating condition? Terminating condition did I mess my declare? I didn't think so. I don't think that's, see something here. Lambda x num declare more x plus 7. That's valid syntax that I did earlier. Okay, scan. Oh, right. I can't do that. I have to do this. That's right, it's a quoted value. There we go. So what this returned is just simply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it didn't return actually the full thing. Let me see. I think it's because of the fact that I have to go in and specify values here. So I keep forgetting that in order for me to print this out, I can't print out. Print only prints out the first thing, but in order for me to show you this, I'd have to print out the values. So I have to do this on REPL. Style warning. Num never used. Yes, I know. There more. Should be actually returning both of them, but for some reason it's not. There we go. There's a syntax error. Values is only giving me, if I do values and it returns values, is always grabbing, it's eating up the first one, the second argument, and deleting the first one. Okay. So what this function is doing is it's returning essentially multiple return values as we normally did with destructuring bind. One of the nice things about this this series function is that you can actually define your scanner as being any given type, and it will actually go through and lazily generate each instance of your type. So this is particularly useful for certain applications that weren't actually anticipated by the use of the series library, because again, at the time that the series library was being standardized, there were still being advances being done in network-oriented programming, and a lot of the common Lisp implementations were built on computers that may not have had access to some of that hardware. So as a result, the actual library itself was designed to deal with different types of data sources, but it was not designed to handle data sources that it didn't anticipate. So there aren't any built-in functions for some of this stuff, but you have the ability to actually go and build those things with scan function. Now, what is the difference between scan function and scan function inclusive? Well, scan function inclusive is something that I think actually I could show with this same example. Let's take this guy out first. This one. Yeah. Ink. Print. Okay. Just make sure. Alright. Scan function inclusive, my understanding is it's going to essentially go one up. So if you say that that the terminating condition is going to be that give me the first 10 integers, scan function inclusive says, okay, I'm wanting the last value that's going to be inserted into that to be the terminating x that's actually stopping the actual retrieval. So it's including the end element that actually terminates the series. So you can use this if you needed to also have the ability to know, well, what terminated the actual series. I won't necessarily say that in a lot of cases this is kind of different than folks who are looking at libraries that normally implements half open ranges, this is a full open range, is essentially what it's doing. Half open ranges is commonly familiar to most programmers, especially folks coming from the C land, where you normally write your for loops where you include the first element and you exclude the last element. So you say for I equals for I int. So I'm just going to write it in C++11, using less than 10, I++. This sort of syntax is familiar to most people. It'll only return 0 to 9. In the scanners, the inclusive one will essentially give you a full open range. This is particularly useful for some things, but I'm not gonna cover where just because I've never actually had those use cases. But if you can think of one, let me know. Let's see, what is the other thing that I want to talk about? So the last few weeks we talked about a lot of essentials on the underlying design of the series library, but one thing we haven't actually covered, but we'll cover now, is user-defined series procedures. We had some examples in our earlier episode when we talked about user-defined series procedures, but one thing that I don't think we really well, at least at the time when I covered it, I didn't go into too much detail, and that's because of I didn't get a chance to go through this paper. But the paper covers is the importance of defining, well, one of two things, and I'm going to show you this with an example. Let me pull up one of our earlier examples of defining a series function. Let's say we're talking about, odd sum. Okay, it's absolutely important, first off, to declare your series functions, that your user-defined series procedures with series defun. Again, this is a different defun than normal CL defun. It essentially hooks into the series compiler. This was what you essentially leverage to essentially register your functions with the series compiler. The one thing you may notice immediately is the fact that we are declaring this as an optimizable series function. This is kind of a hint to that the series compiler is going to be having to do its normal, five rule check to make sure that the function adheres to the rules of static analyzability, straight line computation, the online, offline data flow, and other things before it can actually go do the optimization. Here is where what we were talking about earlier about types inside and the use of types inside the Common Lisp system becomes important, because by allowing series to be aware of what types you're passing into it, whether it uses it through automatic type deduction, I think it does some, I don't think it does all, it will be able to go through and optimize the code. There's two examples in the paper itself that I'm going to just briefly show here, in addition to the one that we see here, and that is series defun collect sum. I'm just going to go ahead and mention it here, folks who are watching. If you guys want the reference material, again, I will post the papers inside the actual YouTube video description, so that you can reference them and then take a look at them yourself. Collect fun, and then we specify the number, the initial value, which is a lambda, and then what was the other one? Series show me. heck is going on? Why is it not showing me the automatic things? Okay, this is fine. We'll just go ahead and do this. This is the function that we're reducing and the numbers that we're passing in. This is a simple example of what we're talking about before. Instead of using collect sum as we had before, we're actually implementing it using a primitive, our own primitive optimizable series function, and we're just going to call this my collect sum because you could see earlier that we're actually using exposed collect sum. What did I do here? Oh, I see. I'm being dumb. No. This is not closed. That's why. For some reason, it did not mention that to me. Okay. I'm going to go ahead and re-indent all this correctly. Okay. Yeah. All right. So this now compiles. This is going to be, again, if we use this as what we were showing before, this is going to essentially do the same thing that we were leveraging before. If we do my collect sum now, then do series scan range from 0 by 1 up to 10. Oops. Print that out. You'll see that it will go ahead and do what we were doing before. And to show you guys the disassembly, this should be similar to the collect sum example that we did earlier. It would give us similar not satisfied as a function designator. What did I do? Hold on.
You can only disassemble a function, not a call.
Oh, I keep forgetting that. Thank you, Michael. And, that's right. Okay.
That shouldn't be quoted.
Shouldn't be quoted. Oh.
The lambda.
I quoted this one. It seemed to generate the appropriate things, but okay. Let's see. 120 bytes with this. What was this one? 126 bytes. All right. I gained 6 bytes. So that's pretty impressive. Okay. So this should be giving us. Oh, that's right, because I'm actually doing more work here than the other one that what I was doing before. Up to is interesting. Hold on 1 second. If I change this to just 2, if I don't get did I mess something up? That's an unknown key argument. That should not do that. Second.
Yeah, it doesn't have 2. It has up 2 and down 2, but not 2.
Scan range does have 2, does it? Huh. For some reason, I wrote it in scan range here, but that, for some reason, did not complain. Weird. Okay.
Well, up 2 is the same as 2. It's not equivalent to loop syntax where it has synonyms.
Weird. Okay. For some reason, that did not complain when I did this before. This is why I'm a little surprised, but okay.
Compile it again.
Oh, one error. It did say it. It just was hidden. Up to. There we go. I just didn't notice it. Okay. 118
yeah,
okay.
The reason why it didn't raise the error in your buffer is because you have that lambda quoted and nothing's evaluated.
All right. Lesson learned. All right. Okay. So one thing I wanted to kind of bring up has kind of something that I'm curious about from folks here is the origins of this library, and the reason why I've been kind of like the last few weeks been covering this in kind of detail is because of some recent developments in other languages I've been using on a day-to-day basis. I've been starting to explore this library kind of very seriously to see if I can adopt some of these patterns, and that is a lot of languages have been adopting a lot of essentially concepts that come straight out of this library. One of them was range-based for loops and range algorithms that are particularly being brought up in modern languages like C++ and even the streams libraries and the associated APIs are coming in Java, as well as related libraries for reactive programming coming in C# Java, as well as C++. These are essentially combinations of two different types of models of computation. One is a pool-based computation and this is where lazy evaluation and what the series library has been kind of designed for, which is, hey, give me the next value for me to do my computation. I can look at the data flow graph. I can actually go in and, do my computation, do whatever the collection, throw it in the sink, move on to the next thing. Very simple iteration that most people are familiar with. But the other side of the things is a push-based model where it is more event-driven. Hey, I have new data. Somebody, let's trigger the pipeline, go through the computation, do whatever it needs to do, throw into the sink. The slight difference between the two is one is the on-demand comes in from the caller, and the request actually comes in from the caller. And instead, what happens is in a push-based model is upon receipt of a piece of information, the pipeline gets triggered. It's more of a notification than actually an explicit function call. So I've been looking into ways of how to adopt essentially series or a series style of development where you can actually go in and define your data flow pipeline and say, okay, now I'm ready, start the scan. Let's go and see if there's anything coming in from our data source. And I'm just curious if others have had a similar thought from looking at this. Now, those of you who are watching on the stream, by all means, put your comments below inside the YouTube video. But I'm kind of spawning that out, kind of putting that out there as kind of a discussion, since we're talking about scanning right now, and at least hear your thoughts on whether or not it would be necessarily possible, if not useful, to incorporate such a model into the series library. I'm still learning how kind of the internals of the compiler works, so that's something that's going to probably be a longer term goal, but I just wanted to bring that up.
Yeah, I'm not sure. I mean, isn't series, like the whole point of series is lazy evaluation? So, I mean, you don't know if there's new data arriving until you actually check.
Yeah, and if you think about how a server works, right? It's it's not doing any computation until something triggers it to do computation, right? The lazy evaluation comes in just merely because you don't incur any sort of computational overhead um, because until the underlying event gets triggered, right? It's not you're not incurring any sort of cost there. Um, but yeah, you're right. That's kind of the underlying principle of lazy evaluation. Um, you're unless somebody asks for it, you don't do anything. But I don't know if that means generation or pipeline triggering, right? Because you could do evaluation that way too. But I don't know. I'm just bringing it up as if you look at a lot of libraries that are coming out right now, most of them, at least in the FP world, um, they kind of unified both models under kind of a common API, and you can certainly use the same API in both constructs with appropriate, documentation and or API like hints to say that this is going to be a push model versus a pull model. But I don't. Yeah. Let's move on. Let's go and talk about altering series. This is something that I thought was pretty neat here. It is, and then we'll talk about one final piece, which is how does it do static analysis? Let's see here. So the example that I was going to bring up is related to the function. I'm just pulling up to make sure I don't mess up on what exactly it's doing the alteration on. But yeah, here we go. So when we talk about transformations, we are not necessarily talking about modifying a particular data structure. Oftentimes, and if you read through the documentation on many of the functions in the series library, the transformations often mean we're going to copy a value and we're going to go in and move it in, return that value. We may cache it so you can do a quick lookup, but in terms of actually modifying the data structure, the modification is actually an appending, not ever an actual strict modification. This actually goes against generalizable expanders, like essentially setf functions, because if you try to use a series macro package, unless the setf is probably happening at a destination, you're almost going to end up fighting with the series compiler. But series does provide you some ways to actually go and alter some data inside your series expressions, and that's through a couple of functions. One is the actual alter function itself.
Well, scan fn. Therefore, your initial value, I think, or wait, no, your step value. You're doing incf there. That's also a setf.
Yes. Now that's a good point. Now the thing is about that is since that's actually the underlying the underlying pointer that's being returned isn't necessarily being is the one that's actually being modified in that function. It's being passed in as a parameter, so it's localized to that particular location, but it's not necessarily the if we print this guy out. The Z structure that's actually being returned by the series.
Huh.
So the internal data structure itself has a separate variable that's using this when it's fun called. And we're just modifying whatever is localized. Now, I'm not saying that it's necessarily going to be the same for, say, consable objects. Like if you pass in an object that necessarily has a cons, but I would think that the analysis would recognize that, and then you're essentially going to end up adding more overhead so that it can do the modification. That's at least how I understood how some of this kind of internal machinery works. It's mostly copy by value.
So is it doing copy on write?
Yes.
Yeah,
internally it'll do a copy on write. The series structure.
I've never really studied series in depth before, so I have very little understanding of it. I know the general idea, but
oh, trust me, I'm digging more and more into
I'm more familiar with closure, which is, I guess, heavily inspired by series. Still, I'm not familiar with series itself much.
Right, and this is why I'm digging into it, because I'm just like, there's a bunch of interesting things in here, and they did a lot of optimizations. But unless you actually, underline, at least start at the API level and then start going into the compiler, you're not going to really understand some of the design decisions from that top level down. But yeah, it's particularly interesting that in order to address this modification, because here's the thing about mutability, right? You do get some savings in terms of certain I/O operations when you're able to mutate a particular variable. I'm not saying that it doesn't have any overhead associated with it, and certainly let's talk about, when we talk about correctness, as soon as you add mutability into the conversation, some bets are out the window, just because of the fact that you have to at least do some sort of due diligence to make sure that you are getting the correct answer, and you're not modifying in places where you thought you weren't modifying. So the way series actually addresses this is through the use of this alter function. So alter takes in, I'm just going to show an example here. I'll put this here at the bottom. Let's start with a simple, let's say that you have a data source, okay? I'm using let's start just for the sake of example here. We have some sort of data source. Let's say that it's some list of characters here.
I hope you're not going to set F that. That's a quoted list.
I am not going to set F it. And we're going to be reading through it through some sort of scanner. Okay, this is our series, okay? This series.scan. Okay, this series : scan. This is what we're actually going to be manipulating. Well, not necessarily manipulate, but it'll... what we're going to do is we're going to first, return a couple of values. We're going to go ahead and we're going to return the original list, so it's just copying it. We're going to then alter the list, and what's altering doing is it's going to take your initial source, and then it's going to allow you to scan another series, and it will go ahead and I think if I remember correctly, it modifies just those locations in the sublist that adopts the series. So it's a one-to-one matching. So what you should be getting is essentially 1, 2 CDF in the second element, and then let's go ahead and return two other things that the paper mentions. which is the data source and the series collect X. Okay. Now, I don't think this is going to print what I wanted to print, but we will see. I'm going to go ahead and copy this.
Yeah, it will. It will.
It will? Okay.
Not if you, if you just call it like that, it will. Don't put print around it.
Okay.
Just CC it.
Non-series data flow X to collect X. What is... That is a series. Let's see here. That is a series.
Well, it failed on the alter line, so put your mouse over that guy.
Oh, let me do this.
What does it say down there? Hover your actual mouse cursor.
Oh, yeah.
Over that. Restriction violation 5.
Alter applied to a series that is not known at compile time. Did I have to explicitly... I didn't have to do this before, but let's see.
Do you have to put it in a series defun and make it optimizable? Maybe?
Shouldn't have to, but this is... Let me go and...
I have no idea, I'm just guessing.
Let me go and do this. This is actually... let me do this. I'm going to check this out. There's a way for me to print out... because series scan should return a of type series. The fact that it's saying that it's not. Non-series to series data flow. So scan is not returning a series data structure?
As your first return value, just print X. Or just return X before series collect X. And then comment the rest out, and you can actually see what it's actually returning, I guess.
I bet you it's finished by the time it does this. It doesn't allow us to actually run it again.
Okay.
If that makes sense. So basically, it doesn't allow us to contact the series multiple times. Because notice, the first time we did this, there's no error. X is not an error. It works fine. So it took
so try removing that first value and see if the alter works without that.
Yep,
yeah,
that's
okay.
Right.
So that must be it then.
Yeah. Doing some sort of optimization that prevents me to only run the scan once, which is a little disturbing, but I learned something today. Okay.
Violation 5 again. Huh.
Why is there a violation 5?
It worked before you did that. That last change, removing the last line.
Yeah, but this is compiled failure. Let me do this. I'm going to do this manually. Test series being, and then I'll go and figure out why I can't put that in a let expression. Series scan list. I know by default it's a list, but the sequence type is the first argument technically. Okay, let's make sure that this is a standard. Yep. Now let's do the series alter test series. Series scan. See what happens. Maybe I also have to say that this is also a list. that is not known at compile time. Which is not known at compile time. Let me do this. Let me put this other list, not this guy, test series 2, series scan. Okay, so both of these are technically variables that should be known at compile time. Again, I think I could do type of on either of these, and it should give me an appropriate basic series. Okay, so now let's go in and, oh, I'm in the wrong file. This is what I want to do. Let's go delete this and reference test series 2.
Actually,
restriction.
Looking up a special variable is a runtime lookup.
Ah, dang it! Really?
Well, yeah, because the stack can change dynamically.
Right. The special variable is a runtime lookup, but that's. I thought that once you define.
I'm not sure this is a good test to run here. I'm not familiar enough with series to really offer any other suggestions besides trying to put it inside of a series defun, maybe. Maybe then it'll actually know that little local variables inside the function, or
let's try that.
Compile time.
No arguments.
I really have no other suggestions because I'm not really familiar enough with it.
Not a problem, Michael. I'm trying to explore this myself. This is a particularly interesting example, though, because I'm surprised that it would not do static analysis against it and recognize they're both of the same type within that let expression. But you might be right. It might have to compile it. Data source. Actually, what am I doing? If this works, let me bring this back because this should have worked earlier. Okay. And there we go.
Neither uses nor returns a series. Huh.
Right, and that makes sense because this doesn't. This is what I was expecting. So to give some context with other folks that are here, when you are defining a series function using series defun, you are essentially registering a function that can be used to be incorporated into the series pipeline. So if I say, for example, here, instead of this, if I actually passed in the data source here with the sequence type, okay, instead of doing it here, and bringing this guy up, this could be used as a series because it's a collector, isn't it? Why would it recognize that? Oh, right. I have to correctly use the collector syntax to actually do that. Yeah. That's weird.
You can free some screen space up and get rid of that bottom buffer by pressing escape a couple times. Or
I can do that. I'm so used to doing that using Spacemax, so I just in Doom, when I moved over to Doom, I just kept that, that itch of not just going into the window and closing it. But let's Let me think here just for 1 minute. This would be... Let me see something here. Maybe it is the quotable list.
Why does it say... I know it doesn't use a series because it's creating one itself.
I think
why does it say
maybe...
it does not return a series? Like, doesn't it return a series at the end there?
Try
series
this.
collect.
Yeah.
So that doesn't make sense to me. Because even if it's one function in a pipeline, I mean in a one function pipeline, it's returning a series. So what the hell?
This is returning. So alter x is returning a series. Collect x is technically not returning a series.
Oh, it's not. Okay, yeah. So it's only going to look at the first return value. That should be a series.
I think so. Hold on. Let me make sure. Series collect. If I do series scan, let's see, what does it return?
Ah, just a list.
Yeah, so this guy is not returning a series. That's returning a series. Let me just do this. Control that. Delete this. And delete this guy because I'm not returning anything here. I'm just going to simplify it so I can actually see what's going on. Alter applied to a series not known at compile time. So
okay, now do that. Now do that form inside your viewFun in the REPL. The simplified form. Stick that in the series viewFun. Because now it's returning a series. So at least one warning should disappear.
And let's do this. We're not going to take that guy. Okay. Series not known at compile time.
I think you had the optimizable in there in the REPL. I forgot what you.
Yeah, we have to do that. Yeah. Declare series optimizable series function and style warning, but that's fine. What is the style warning? Example is being redefined and is previously. Oh,
compile it again. It's because you already have an example function.
Yeah.
For macro. Optimizable series function that uses this and returns a series. So.
Why is alter should be returning a series? That's why I'm surprised it's saying that. It's essentially saying that alter is not. Let me go through the documentation here just one time. Alter modifies data structure underlying the series destination.
Are you sure you have the syntax right for that declare? I mean, you probably do. It's just confusing that it says that optimizable series function neither uses nor returns a series. But it's like, that's not the name of the function.
This is based on many examples that I've gone through.
Okay. I guess the error messengers are pretty confusing.
It's by you specifying that it's an optimizable series function. Oh, wait. Oh. I don't think we actually need to specify that unless we're trying to optimize. Warning. What is this? Alter applied to a series not known the compile time. Let's see what happens when I do this. Example. Huh. Let me redefine this. Let me rename this guy. Alter example. Okay. Alter example is defined. I just defined it. Oh, compilation failed because of a warning. Series optimizable series function. Weird. It warns and then it complains. Let me go to this. Hold on a second. Alter rest stuff.
Apparently there's a define optimizable series function. I don't see anything in the documentation about the declare though.
If you look at the examples in the user manual, a lot of them use that declare when they're registering a user-defined series procedure to the series compiler. I'm not entirely sure why the documentation does not explicitly say that you need to do that in a declaration. I've just seen enough examples of it that I think it's just a declaration that that's part of the registering of it, because there's no other way of calling optimizable series functions. At least I haven't found an example that calls it explicitly inside of a defun. But yeah, let me figure this out. This one is saying that the alteration process stops as soon as the input runs out of buckets. X is unchanged.
Okay, so in looking at the examples,
yes,
it's saying that the declare optimizable series function is to be used in regular CL defun.
Oh, okay. Weird. So you're saying something like
unless I'm just reading it wrong and it's actually inside the package, I don't know.
Does not look like.
I think this needs better documentation or some book or something.
Oh man, that would be an excellent idea. There's and since I've been going through this, I may as well start figuring out where it is.
I think I'm wrong actually. Ignore what I just said. I think all the examples are in the series package.
Almost all of them are using series : defund is my understanding, but I could be wrong. I've seen a lot of work. I mean, I have a lot of working examples in this workshop here that does it, and it looked like that they were working because I'm able to use, like, say, normalized max and odd sum and other things using their built-in things. So
I see some examples in the docs actually pass an argument to optimizable series function, like they do optimizable series function 1 inside of a list inside of declare. I'm not sure what that argument is.
I think so we can get into that. That is, I think, used in the underlying analysis, at least from what I was reading in the second paper, because they do a formal. So what series does behind the scenes, okay, and this is going into the weeds a little bit, but since we're talking about series implementation, it's a good thing to know. What it does is it creates a control flow graph. So for folks not familiar with compilers, when you create a parse tree, prior to actual doing code generation, some fairly advanced compilers do different types of analysis on top of the parse tree, which represents a control flow, like how data and actually, more importantly, logic moves between different code blocks inside of the graph. And there are different types of analysis that can be done, and based on the particular algorithm that you are leveraging, certain optimizations are, brought into the code generation.
I see now. The integer that you specify in the declare,
yeah,
that corresponds to how many values that function is going to return. So that could be a problem with your original one, since you weren't specifying that it was returning 4 values. In this case, you don't need the 1 because 1 is the default. But when you had the values there before, that could have been an issue. It defaults to a 1 after optimizable series function.
Okay. Let's see this.
So 1 would mean it returns 1 value. But if you return more than 1, you need to update that.
Why isn't that showing up in my mini buffer?
It won't. Declare is not a function or a macro. It's just a symbol. Yeah, it's up to defunt to parse that out.
So I should say 4 here. And you're saying that
not anymore because you don't have values. If you were to add them, then yeah.
Okay, so let's see if
you could have just left it in because you only have 1 return value, which is the default for the optimizable series function.
Okay.
It says integer default of 1 specifies the number of values returned by the function being defined. This cannot necessarily be determined by local analysis. So that is why it's specified.
Hold on a second. For some reason, my buffer got messed up. Test series. Okay. Why can't I hit the return button anymore? Okay. Let me set something here. Okay, at least my return button on my keyboard is not messed up. Otherwise, I would have been very, very mad. Data source. No, we did series collect X. Okay. And it did that, and then it had. Data source and series collect X. So that's the before, the altering, the after. Okay, let's see what happens here. Unbalanced parentheses. Of course there's unbalanced parentheses.
Well, it would help if you didn't have such a long line.
I know. For some reason, it wasn't allowing me to hit enter until I just finished the unbalanced parentheses.
Yeah, that will happen if you have an error in the buffer that it wants you to correct.
Okay.
You'll have to, there's a key binding to remove the compiler notes from the buffer.
Okay. I'm telling you, I can do that. But anything else? Let's see this. It's still complaining, but look.
Well, this time it complains correctly because series collect does not return a series.
Yeah.
And if I'm correct that it's only looking at the first return value as, you know, like a normal function, like the
yeah.
First return value is the only one that's...
What bothers me is I can't just simply paste this guy and have this just work in my REPL. Because that's a little concerning for me. So I must be doing something wrong. Oh, yes. Now that's complaining because of the fact that I took out my data source here. Data source, yes. List ABs, yeah. ABC. You're so lazy. What? Now that worked. What changed?
Well, it is complaining about things, so you gotta scroll up and see what the problems are.
Yeah, but earlier it didn't even we didn't even get that far. That's the thing. So I'm wondering what went on. Series. It's a series collect X. It says. So let me pull this up and let's go through this. Let's see. Ah, I see what happened. It modified the underlying data structure. Yeah, that's what I thought it would do.
That would be a problem.
And since it didn't return anything, that's clear. It's a nil. So since it didn't return anything, it's a nil. So to cover through what these 4 return values are doing, the first one is just grabbing whatever X is a series object. So series collect is essentially copying everything that's in the series object into some sort of data source and returning it. By default, the sequence type is a list, although I think you can actually specify the sequence type to the underlying.
I was kind of hoping that this would work correctly because I wanted you to test something.
What is it that you want? Okay, so let me just cover this, and then we can try this.
Okay, I'll explain if you, when you're done then.
Okay, so to go back to this, what alter is doing and this is something that I just learned right now. I thought of one thing. My understanding of the documentation was that alter would actually return the altered, a new instance of the altered series. But what it does instead is alter actually takes in the destination, which is X, which internally holds a copy of the data source, and it modifies the data source.
Yeah, but it's not going to create a complete copy.
It's not a complete copy. It's
that's
a shared.
What I was going to get at with my example. Like, what if you had like a list of, I don't know, class objects or something? Like, it's only going to copy the list. It's not going to copy the class objects themselves, the instances.
Right. You're thinking that
tables or anything that's reference based like that.
It's going to be you're thinking that it's going to be a shared structure, right?
Yeah.
Essentially. Yeah.
It's only going to probably copy the outside sequence of elements, not anything. And it's a shallow copy.
Right. It's a shallow copy, not a deep copy. But that's fine. If it's still necessary. And you're right. That is something to be aware of. The one thing though that I thought that it would do is alter would return that. Instead, alter doesn't return anything. Alter instead is just saying, okay, you want me to alter this thing and create a series of it. That's fine. And the data source that's pointing to it is the one that ultimately got altered, which is weird. I really thought that it was something else.
Alter changes the series destinations so that it contains the elements in the series items.
Right.
More importantly, in the manner of set up the data structure. The alteration process stops as soon as either input runs out of elements. The value nil is always returned. It says it right there in the docs. The value nil is always returned.
Did I miss that? That's probably why.
Line 942 of the example file, the doc file.
Oh, I'm an idiot. It says it right there in the function signature. Alter destinations items arrow nil. I need to read the function signature a little bit more closely from now on. This is me being. My apologies, folks. This is me being somewhat stupid. The one that we wanted to use is toAlter. Alterable series are created by this function, and the toAlter will take a series and return an alterable series containing the same elements. Alter basically returns nothing. It just
it's specified to always return nil. So
that's. But what's interesting is it's a modifying data source, which tells me that X internally, the series data type, keeps a pointer to that data source, which is.
Yeah, this is getting into transducers and everything like that.
Yeah, I mean that's. I kind of expected that. It's not a. I didn't think that it was a transducer because it should create a new series. toAlter is a transducer because it's creating a new series, it looks like. It's creating a new series. So if we end up doing, say, scan list on that, we'll have a different thing. But what's weird about this is if you look at the documentation, I'm reading again the examples that are in the paper. There's an example where he's using alter. Oh, never mind. He's returning the data set. Yeah, that's right. I'm being dumb. Okay, so he's basically returning the altered data set through the use of X. Okay. Never mind. That's just me misreading that code. So let me go through one more thing, and then. Whoa, I'm a little bit surprised. Hope all you guys are having a little fun here today. Let's see here. Let's bring back this one thing. Okay. So very quickly, let's cover toAlter, which is.
Well, at least it works.
Yeah, at least
not what we were expecting.
Not at all what we were expecting, and that's okay. That's kind of nice about having exploring this library. It's like you see all this really interesting thing that it's doing. Nice. Okay, so this is an example of that. I'll check it. Like I said, as with everything, I'll check all this into the AFP repository once I'm done. Our final example is going to be this little list, and then we can. Oh, wait, Michael, you wanted to actually try something, didn't you? Michael?
Oh, sorry. Yeah, not anymore.
Okay.
I wanted to see what would happen with it a nested list, like shared structure. But
now
that I know that it's going to return nil, it doesn't matter anyway.
Yeah. So we do this. Let's try this other one. Hold on 1 second. I need to print this guy out. Data source. Oops. Data source. Okay. We're going to go back to our little data source example. And we're going to do toAlter instead. Go through that. We're going to make a smaller set here. A, B, C, D. And then X is going to be, again, our series on the data source. Okay, so now what we have to do is shoot. It's using that hash M. I've now got to remember what the hash M reader macro did. What was the hash M reader macro doing? It creates different sublists, but let's see here. Let's change this up. Let's see if we can do this without a different thing. Series toAlter. Now we specify the series, and we specify the lambda function that represents then the parent. Let's see here. No. Let's say that we're going to alter this and just replace it with let me see, what can I do? You know what? I'm going to replace these with numbers because we'll do y equals 0. Okay. Just so that I know which variables I'm actually dealing with. Set f z to be y, and then increment y. Okay, and I think that's all I need to do. And if I return this guy, this should give me 0 compiler nodes, but doesn't print anything. Okay. No, it actually did return something. Oh, it's because I forgot to actually, like a dummy, forgot to return something here. Data, so it should return here. Okay. Nothing actually got removed. Interesting.
toAlter is supposed to return things itself.
Yeah.
I don't think it mutates like you're expecting there.
Let me do. Wait, toAlter returns.
Returns an alterable series A containing same elements of the series.
The same elements. Other input, each of which, did I misunderstand this? So it's returning alterable items. Oh, it converts a series into an alterable series.
Sounds right.
Okay. This is what they were talking about in the implementation, saying that Many scanners produce alterable series, but many do not. Okay. Since scan actually is already an alterable series, it's not going to do anything. It's going to just return A, B, C, D instead. Okay, that's the thing. Okay, that's my misunderstanding on what it's doing. It's not actually going to do any sort of altering at all. So, how would we use this? Oh, they gave an example right here. Let's try this. Okay, D Shift G. Let's do this. We're going to use scan list. We're going to define a let's say create alterable series from the list. A list, so I don't confuse myself with the list function. Declare series optimizable series function. What we're going to do is we're going to grab the sublists of this guy using series scan sublists on a list. And what we'll do is we're going to call series to alter on this series make series sublists. Our lambda function is going to be lambda new parent. And
is series make series the #m thing?
Yes.
Okay.
That it took me a while to recognize that, but I think if I remember correctly.
So is that still the same as the example though? Because they're doing #m car of sublists.
Yeah, I thought it was, but let me go and verify that. I was looking at this.
Like, I don't know that. Like, you can tell this library's old. It's using all these reader macros.
Well, they didn't use reader macros. We took out. We're discouraging reader macros now, right? So.
Well, it's not that we're discouraging. We are discouraging them, like, for a few reasons, though. Like,
I mean, it makes sense. I'm not saying that it's not a bad thing. I'm just merely saying that this was designed before that style got accepted.
But the problem with the reader macros is if you define one, right, that's available throughout the whole Lisp image, so you could be potentially overriding other reader macros of the same name.
Yeah.
And there's no standard way to avoid that. There are some libraries which basically force any users of your library that defines a reader macro to put an annotation at the top and the end of their file in order to load your custom read table and then restore the default one at the end of the file. So it's really cumbersome because it puts all this burden onto users of your library.
Ooh, I missed that. I misunderstood what that was doing. It's not make series. #m car is map func.
Oh, okay.
So this is #m car map fun, and then we specify the type, which is what was the type? It says the reader macro is a non-series. To activate, you must make it. Oh, I don't care about that. I'm not asking about installing the reader macro. Type this, I guess. Do that. Then the function is car on the sublist. Yeah, I think that's correct now. And then we go back to this example, which was in the alteration of values.
Set of the car of the parent to be new.
Yeah. Car of the parent to be new. That's it.
And then
return
on sublists. So the third argument to alter is sublists.
I think that's it, and then we'll return, right? Yeah. Compile, no warnings. Yay! Okay, that's
a first.
Oh, there's always a first.
It's a miracle for a library like this, really.
Yeah. Well, you should have been here last week when we were covering the closure example of actually implementing series from scratch. It's on the other window. Actually.
Oh, fun.
Yeah, that one, like it worked on the first try. I was like, holy crap! I can't believe it. Usually, my demos require me to actually figure out a while why I'm getting compiler errors in a library, but the library and the examples are very well made if you actually understand what they're doing. So I'm just gonna say that if you don't understand what they're doing, you could see what I do, which is be a bumbling idiot, try to figure out what's going on. Okay, so what we're going to do here is we're going to alter, we're going to choose. Anytime, and folks who are reading the documentation, this is something I guess I should have brought up before, but I'm going to bring up now. #m is all over the place. And and I'm going to write a note here in this example so that you guys have it in your own reference. #m is equivalent to series map fun, which is the generalizable mapping function inside the series library. So you can specify what the type is of what it is that you're mapping on, and then you specify the map function, and then you provide all the arguments. So in this case, what we're going to do is we are going to choose, if I remember correctly, this is a list, then it's -p, and then x. So what this is doing is we're figuring out if a particular thing is a minus or not, and if it's a negative number, we're going to alter that specific location with a 0. And then we're just going to return data.
Series what?
Did I mess up something here? You said series what?
The function series on the end of the long line there. That's
series :
that's
series.
Not a function, is it? Okay. Series? That would make more sense.
Yeah. Series is the package name, and series is the name of the...
Okay. Yeah, it wasn't in the CL user package.
Yeah. Scan list should have been available, though. Scan sublists. Can't scan lists of lists, but no scan list. I was under the assumption that there was a scan list. Is that an internalized one? Because there's a bunch of them.
It's an internalized one. It's actually refined. You defined it yourself above there.
Oh, did I? Oh, yes. Create alterable series.
Whatever you called it.
Yeah.
Yeah, create alter, because that's what it's called in the examples.
Yeah.
Scan list.
There you go. Data is unbound. Why is data unbound?
Because it needs to be a let star.
Wait, it could... Oh,
it needs to be a let
right.
star.
Got it. Yeah. Compile, alternate series. What is it?
Oh, here we go.
Yeah, I know. This is the real meat.
Errors in the semantic analysis of it all.
Extend. Unreachable code. What? Choosing line 65. Break on signals.
Error 65. Are these error codes documented anywhere? Because there's a lot of them I noticed.
Yeah, they're in the code.
Code. I shall look at that then.
They're in the source code. So I have to go and this is when you said that this needs to have some slightly better documentation. I'm taking that seriously. I'm going to try and see what I can scrounge up in terms of what's there and try and come up with something slightly better. Although I'm good with content.
They're not documented at all. Just throwing error codes everywhere. This is fun.
There's error codes everywhere with no documentation. Yeah.
But I see anyway. I don't see any documentation for the actual error codes. I'll have to look harder.
Yeah. I bet you it's basically an enum that's being converted somewhere. I bet you. At least that's my... if he's using hard-coded numbers, that would be like, okay, thanks. You need to... I love the design, but I need to go and figure out why you do that. I'm going to go ahead and make this so that folks can, instead of being so... I thought it would be more readable, but since people are going to be looking at other things here, it'd be just useful to have this all match up.
Yes.
Okay. It says deleting unreachable code. Oh, because it's throwing up an error. Unalterable series. Did I mess up the T? Code truncate. Let's see here. Scan list, data. Sublist. Okay. This is
yeah, there's not even a table of enums or anything. It's just error 65, error 72. Like, what?
Wow. Dr. Waters really wanted people to memorize some of the error codes. Oh, error 65. I know that. I was getting that all the freaking time. That's a so, okay. This is something that I need to go and dig in, really. I think we're going to have to call it, just because I'm not entirely sure how to actually fix this. Because I have to go and figure out what error 65 actually means, and then I can go and tell you what where it's doing it. Let me check just one thing here in the output.
I think 65 means that alter was applied to an unalterable form.
Yeah, that's what I'm thinking too. But why wouldn't it be alterable is the question. That would tell me that toAlter did not correctly... I didn't correctly return.
And the only reason I found that is because I looked in the source code, and there's a few functions that raise error 65, and one of them actually produces a string with it. Like, it's not consistent or very well documented at all.
You mentioned error 72, so I was like, okay, wait a second, maybe 65 is somehow connected with error 72.
So somehow that sequence, or that, somehow toAlter is not doing its job.
Yes. toAlter is not doing its job. Or either that, or I messed up here when I'm converting the sublists. Thus having it return the wrong thing. You know what? Let me do something here. Before I even do this, let's comment this guy out. And just return this. Why does it print?
It probably did above all the noise there. You have too many warnings to notice.
Okay. Let's see.
Oh no. Variable access.
Scan list is what I wanted to actually return, not max. So check. Common Lisp scan list is not. I defined it earlier in my image. I thought this. Oh, I'm dumb. Sorry, I have to go through this. Comma. How do I change and do Emacs to?
Comma RS. I think.
Comma RS. No.
Comma RS.
This is well, I'll just do this.
Oh, maybe that's something I added to Doom. Could be.
Hold on 1 second. What is the name of this package again? There. Series examples. In package. In package. Set package. Series.
You want to call fly mrepl sync in your source buffer, and that'll do it.
In my source buffer, I do
sly mrepl sync. See what key bindings next to that. Space mrs. So comma rs.
Comma rs. Okay, space mrs.
Actually, it's space mrs because in my config I make local leader comma, but in yours I guess it's space m.
Yeah, I haven't actually gone in bindings and made a shortcut key for space m, so I'm messing with that. So this should now work. If I do this, basic series error printing object. Okay, great. I like it.
Great. So
let's do this.
Yeah.
Nope. I don't do anything there. So why is it having trouble printing this guy?
That could mean that there's a print object method defined for series, the series, and one of its arguments is invalid.
Yeah, that's what I was thinking.
Or unbound or something like that. I don't know.
Basic series.
You could do break X and then inspect it in the inspector. See what it's actually. No, that's a bad idea. Never mind. I couldn't tell you.
Yeah.
Something about the print object method, though, it can't be evaluated.
I don't know about the internals of this. I never hit this error before, so this is brand new to me. Okay.
You can click on. Oh wait. Series, basic series. Oh, that's what you clicked on already. It's a structure object. Data so far nil.t.
Yeah, data so far is internally what it's generated. It's its cache. But I'm wondering if the problem is in the generation function, the closure that was constructed. I don't know. I'd have to go and look at the code to figure that out.
Yeah, it's too opaque.
Yeah.
I can't really tell by looking at the data structures. What
the beauty of opaque data types. So opaque.
This is a black box and it's doing magic stuff. You're on your own. Go read the code.
Yes, that's pretty much what I'm going to suggest right now. At this point, I'm just going to say that for toAlter, There's some weirdness going on. I'm not entirely sure what's going on there internally. If I had to guess, it's some invalid closure that's generated when when two alters are actually being applied. Actually, more importantly, it's when the map function is being applied. But that's me speculating. I would rather have you guys take a look at the source code and go from there. Okay, it's. I'm going to end this here before I completely embarrass myself going through the source code and do some spelunking and trying to figure out some stuff here. I'm hoping that that you're coming away with this, that Series is a fully functional library with a very basic design methodology. All right, and that is you are dealing with one specific data structure the entire time for of your program. There is a underlying variable that is essentially encapsulated, as you saw with the alter function, that Series will modify accordingly based on which whether you're calling it on a transducer or whether you're calling a collector and so forth. There are many other functions that are built into there. There is an optimization that what they tend to do, and this is, I'm going to just close this off here, and that is for folks interested in the more compiler-oriented things of Series. Series essentially does a live variable analysis on the code prior to actually doing code generation, so that it can actually figure out the blocks of code that adhere to the Series philosophy, specifically the straight line computations that we discussed in the past episodes. And if it finds a cycle in the control flow, it will do certain things, but then, as you saw here in some of our examples, it might actually go and spit out error messages accordingly to saying that a cycle is available, it can't alternate a particular series, and thereabouts. There are many error codes, as you saw that in our kind of demos today, that are a little opaque in terms of how they're sped out to the REPL, but if you pay a little close attention to it, it looks like they do specify some details as to what it is complaining about. For example, what we saw with error 65 being altering being applied to an unalterable series. But at the end of the day, this live variable analysis essentially will figure out what optimizations can be actually provided by Series to convert your stuff to the appropriate loops. So I'm going to end it here. If there are any questions and you don't have the time to actually go and present them, please post them in the YouTube comments. Folks that are on, do you have questions at all? Post them up.
Nope. You guys doing
there
Series
is
next week too?
We may be. I'm open to suggestions on that. I was going to actually see if I can do that one example, that push-based example that I was bringing up earlier today, just to see if I can get that in, because that would be a very, very interesting and very useful example, because that would mean that I could actually take a socket, an open socket, and hook it into a series, and then do some transformations on it, as long as the compile time, certain compile time optimizations are available. If it's fast enough, you can now do push-based computations using the same library, which would make me happy rather than trying to figure out how to do reactive-style programming in Common Lisp differently, like reviving cells or something like that. Because reviving cells itself is, it's a complete library, but I don't know what bugs linger around in there since it hasn't been maintained for so long.
I don't know anything about cells. One library that's, complex and has its own compiler like Series that I would eventually like to see being discussed is Screamer. That's really interesting.
Yeah, I know. When Jace brought it up originally and showed what Screamer is involved, I was like, I have to figure out like a concrete like program that we could then start from, and then dig into Screamer based on that program to see what it's doing underneath. So if you have ideas on how to do like a problem where Screamer actually fits, I'd love to discuss that so that way I could come up with a primitive prototype of it, and we could dig into the internals of Screamer based on that prototype. That way, people come out with a concrete saying, oh, this is a use case that Screamer does, and this is what it does internally for that use case. One question was brought up actually related to the 2 colons after defun. So I don't believe defun is an exported symbol in the series package. At least I don't recall it being an exported symbol in the series package. So if you want to define a series function, okay, that is something that's being registered by the series compiler and hooking up to the series data type, I think you have to call the internalized function. I know you shouldn't do that. It's not an exported symbol, but maybe, if someone can fix that and let series defun be an exported symbol so I could just do a single colon instead of double colon, that would be great. But until that happens, series, as it stands today, doesn't actually expose that. I hope that makes sense.
Yeah, normally you shouldn't really do that because you're, going around the protocols that the developer provided for you, but in this case, I don't see series changing anytime soon.
Right, exactly. Okay, great. All right, I'll see you guys next week. Appreciate all you guys joining me. If you guys have any comments regarding series, or if you want to see some additional talks, let me know. I squat usually in the Discord server and on functional programming Slack. So